Please make sure you have your packet open to page 4 so that you can correct the problems that you should have already completed by yourself. The first problem gives us 3 combinations of tables and pizzas with different amounts of people, different amounts of pizza, and we need to think about which table has the guest getting the most pizza. So you have a small table with 5 seats, so for 5 people, and 2 pizzas. We have a medium table with 7 people and 3 pizzas, and we have a large table with 12 people or 12 seats and 5 pizzas. So today in class you probably talked about comparing these values, and you might have compared people to pizzas or pizzas to people. When I set these up, I'm going to compare pizzas to people because I want to know how much pizza each person is going to get. Again, you could solve it a different way, but this is just one suggestion. So if I want to compare pizzas to people, the small table is 2 pizzas to 5 people. So if I think about how much each person's going to get, so for one person, I want to know how much pizza they're going to get. So this is a scale factor of 1/5, and 2 times 1/5 would be 2/5. So that means each person is getting 2/5 of a pizza. Or you might think about that as a percentage. Each person's getting 40% of a pizza. At the medium table, again, we have 7 people, but I'm going to put the pizzas on top. So pizzas divided by people so that I know how much one person gets. So in this case, my scale factor is 1/7. 3 times 1/7 gives me 3/7. And I'm going to think that each person is getting 3/7 of a pizza. As a percentage, that is 42.8%. I'm going to round that to just 43%. And so now finally I have my large table. And so again, I'm going to take my 5 pizzas and divide by my 12 people so I can figure out how much one person would get. This is a scale factor of 1/12. And when I find 5/12 for one person here, I'm going to think about what percent of a pizza that is so that I can compare them. And 5/12 would give us about 42%. It's about 41 hundredths and then another 6 after that. So I could round it up to 42%. So based on the relationships here, I'm going to notice that the medium table is getting the most pizza per guest. On problem 2, I'm going to scale up some ratios. So for A, I have 6/14, and I want to find out what that makes out of 21 and out of 28. You might think about how you can simplify 6/14 to 3/7. That might be easier for you to scale up. So then I can recognize that 7 times 3 is 21, so 3 times 3 is 9. So this missing value should be 9. And then out of 28, I know that 7 times 4 would make 28, so 3 times 4 would make 12. You might have also thought about how 14 times 2 would make 28, so 6 times 2 could make 12. For problem B, I'm missing a number at the front, and I have 8/36, and I need to think about this ratio. So for B here, I want to think again about if I can scale down this starting ratio. So 8/36, if I divide by 4, 8 divided by 4 would be 2, 36 divided by 4 would be 9, so I can simplify to 2/9, and then I can build it back up. So 9 times 3 would make 27, 2 times 3 would make 6. Same thing if I want to scale it to 63. 9 times 7 would make 63. 2 times 7 would make 14. So these missing values should be 6 and 14. The last two that are here, for C, we have something out of 20 equals something out of 25 equals 6/30. Again, I'm hoping you can see that you can scale that down. So 6/30, if I divide, or for example, if I multiply both by 1/6, I get 1/5, right? Because 6 divided by 6 would be 1, and 30 divided by 6 would be 5. So now I can scale back up. So 1/5 is equal to how many 20ths is equal to how many 25ths? Well, this is 5 times 4 to make 20, so 1 times 4 would be 4. 5 times 5 is 25, so 1 times 5 is 5. So these missing values are 4 and 5. And the last one here, I'm running out of space, so I'm going to erase a little bit. For D, here, I'm going to think about something out of 8 equals 15 out of something else equals 24 out of 32. So let's see if we can simplify here. 24 out of 32 can be simplified to, well, if I divide by both of these by 8, for example, so multiplying by 1/8, I can get down to 3/4. And I can scale that back up to something out of 8. 4 times 2 would be 8, so 3 times 2 would be 6. That's my first one. And then I can think about how would I scale 3/4 to 15 out of something? Well, 15 times 5 would be, or sorry, 3 times 5 would be 15, 4 times 5 would be 20. So the second piece here should be 20. Again, to know that all of these are equivalent to each other, you should be able to reduce all of them to the same fraction in simplest form. So in this problem, we're going to write statements comparing the areas of shaded and unshaded regions. And so it might be easiest to start with the ratios. In this case, I can see for diagram A that there's 2 shaded regions to 3 unshaded regions. In B, I can see I have 1 shaded region and 8 unshaded regions. When it comes to fractions, I want to think about probably a part to whole kinds of situation. So again, these ratios are part to part, for example, because I'm comparing shaded to unshaded. When it comes to fractions, I usually want to do part to whole. So in this case, I'm going to use 2 to 5, which are shaded, or 3 out of 5 are unshaded. On the other situation, I've got 1 out of 9 are shaded, and 8 out of 9 are unshaded. What about percentages? Well, in this case, 2 out of 5 would equal 40% that's shaded. 3 out of 5 would be 60%, which is unshaded. In the other situation here, I've got 1 out of 9, and 1/9 is equivalent to about 11%. So 1/9 equals 11%, that's shaded. And then another way to figure out the other percent would just be to subtract. So if 11% is shaded, that means that 89% is unshaded. Finally, you have some multiple choice questions. So choose the value that makes this proportion correct. Well, let's find a scale factor since these are similar or equivalent ratios. So 3 times 1/2 is 15. In other words, half of 30 is 15, and half of 18 is 9. So my answer should be H9. For number 5, I want to choose something that makes this statement correct. So something out of 15 is less than or equal to 3 out of 5. It might help if I scale 3/5 up into something out of 15. That way I have a common denominator to compare. So I'm going to use the scale factor of 3, because 5 times 3 makes 15. 3 times 3 makes 9. And so now I know that something out of 15 is less than or equal to 9 out of 15. So if I look at some of these numbers, for example, 12, if I put a 12 here, 12 is not less than or equal to 9. And I can test out the other numbers if I want. The number I should be getting to is A9. 9 is less than, or in this case, equal to 9/15. So 9/15 again is equal to 9/15, so it satisfies this statement. That's it for your homework tonight. We'll see you Monday.